I'm Chris. That's my name. One of the benefits of being old, you might notice the picture that I had before was a few years ago, and in the meantime, I've got a lot more gray hair. But one of the benefits of being old is that my name winds up being used everywhere. Yay, C. Winters. So that's me. So GitHub and Twitter and all that fun stuff. So I work at Turnitin. Turnitin is an educational technology company, headquartered in California, but we have an office in Pittsburgh, in the Strip District. And we work on, basically, we help kids learn to write better, which is really fun. So what are we going to do? So this is not a Docker tutorial. If you want to learn how to actually use Docker day to day, there is a lot of information on the internet about it. And I'm not going to tell you anything in a half hour that you can't read better on the internet in your own time. You don't need to know anything about Docker for, hopefully, to understand this. And what I'm trying to do is kind of convey how Docker sees the world and how that's actually really useful, how it can be really useful for you. So I'll tell you two main things. The first one is that Docker lets you name and share the things you build, which sounds really easy and simple, but it turns out to not be. And Docker gently, or not so gently, pushes you into thinking about the world in terms of 12-factor apps. And we'll talk about that a little bit also. How many people have seen this quote before? A few. So there are two hard problems in computer science: naming things and cache invalidation. It's from a guy named Phil Carlton from the mid-90s. There's a variant on this which adds off by one errors to that. So two hard problems: naming things, cache invalidation, and off by one errors. And naming things is really hard. One of the things, so I used to be a Java developer, reformed Java developer. And one of the really nice things about Java tools and about tools for static languages in general is that you can rename things and know that they will be renamed everywhere. So you don't have to think as much about naming a class a particular thing or naming a variable a particular thing or a method, because you can hit Alt F7 and everywhere in your project it will get renamed, even in XML, which is pretty great. But naming is really hard, especially when you don't have that. And we have all of these things around us that are the result of naming abstractions, right? Like you think of saving a file. Well, there's a lot going on when you hit Command S, right? Or just the idea of a file. Like we have these things that existed in the real world at some point, and they kind of exist sometimes now, and sometimes they don't. And we settled on these naming conventions or affordances from the real world kind of a long time ago for a lot of these things. And my main example is this. So one of the other benefits of being old is that I worked with these for a long time, and they were really valuable at one time. There's a movie, 16 Candles, I don't know if anybody remembers that. And they trade floppy disks, right, because they're really expensive, and this becomes a currency among the geeks. But like now, one of the podcasts I listen to, one of their phrases is, there's somebody born every day who's never seen the Flintstones. And there's somebody born every day who's never seen or used a floppy disk, which is a good thing. So this doesn't really fit anymore, but we still use it everywhere. You see this icon everywhere. So another naming affordance we have is, for developers particularly, is tags. Who has used tags before on things? And they're basically a hedge because we don't know what we want to name things, right? We say, well, there's this problem, there's this thing, I kind of know what it is, I might want to call it something else later, so I'll just call it lots of different things and hope it kind of works itself out. Does it? Kind of. Sometimes it's useful, sometimes it's not. Anybody know who this guy is? It's Rick Seebeck, Southwestern Pennsylvania icon. He's a Pittsburgh documentarian. He's made lots and lots of shows over the years. One of them is called Things That Used to Be There, right? And it's kind of referring to the Pittsburgh tradition, maybe it's up here too, I'm not sure, of giving people directions in referencing things that used to be there. So turn left where the Willies used to be. And if you are new to the area, that's extremely confusing because there's no Willies there anymore. I'm not a native Pittsburgher, by the way, and this was kind of confusing. So one of our favorite names as developers is a version, right? And a version means something. It's kind of a stamp of approval. At this point in time, this is what my code means, right? And it's a name that we publish to the world. The problem is we imbue that name with a lot of meaning. And retroactively, we kind of try to do things like semantic versioning, right? So we've used versions and versions for years and years and years among open source projects. And then somebody kind of said, well, these things, everybody thinks of these things differently. Like Linux has for a long time, its version numbers mean specific things. But that's not true for everything that Linux uses either. So somebody kind of tried to retroactively fit semantic versioning on lots of things in the open source community. And it has great intentions, but probably it has worked well in some cases and not well in others. So one of the reasons it hasn't worked as well is because everybody has to buy into it, right? So it's kind of a tragedy of the commons problem. And we use versions for distribution, and it works really well. But unfortunately, no code is an island. So this is a Java, or actually, yeah, this is a Java dependency tree, basically. It's a lot of trees. Maybe it's a forest, right? And this is kind of one of the trade-offs of how we develop software now. So if you go back in Google and you search for the term integrated software components, you'll find articles from like predating the web, which did exist. And the idea is that you would focus on your problem. I'm in educational software, and I focus on educational software and all the things around that. But I would be able to plug in other things around that and be able to make my application. And we're actually closer to the dream than we ever have been since software has existed. Because we have all of these utilities and ecosystems for distributing software. We have NPM and Ruby Gems and Maven and all these sorts of things. And CPAN, any Perl people in the house? Yeah. My Perl people. I'm C. Winters there too, by the way, on CPAN. And honestly, this whole ecosystem has, I would hazard a guess, given us all jobs. Because without the ability to stand on the shoulders of all sorts of other people, we would be stuck kind of reinventing the wheel over and over again, and it wouldn't be as fun. So it's super easy to get your software out into the world right now. And it's easy to version it, and it's easy to distribute it. You know, there's command line utilities to do this. It's basically as simple as a git push in a lot of cases. And it's really easy to make frequent releases. But the problem is all of our dependencies do the same. And their dependencies, and their dependencies, and their dependencies. And there are ways to fix this. If everybody specified exactly what version of the software that they work with, then we wouldn't have as much of a problem. But people don't do that because they don't want to have to monitor their dependencies and their dependencies and their dependencies all the way down for things like bug fixes and security fixes. So you say, well, if this is version 2.x, I'll be okay with it. But what if they upgrade to 2.1.2 and they update their dependency to something else, which breaks something further up the chain? Anybody ever had this problem? Just this is what it feels like, right? And it just keeps going back and forth, and you don't have a lot of control over it. So this is where we bring Docker back into things. So Docker images and the ecosystem kind of make your version a more real version of itself, or a more concrete version of itself. So a little bit of background. A Docker image is a result of a build. So you run a command, and you put a bunch of software, and you stuff it together, and you give it a name. Every one of these images has a unique hash ID, just like Git. And there's a lot of like Gits involved with Docker. And every image is immutable. So, which means if you have an image of software and all the stuff around it, and you add a file to it, you don't change that old image, you make a new image. And just like Git, every image can have any number of tags that can reference that. So they can be version numbers, they can be happy unicorn, skippy rainbow, whatever you want it to be. So what does the build look like? This is actually a build for this presentation. Just kind of meta. So Docker is the first line up there. Docker is a binary. It has a client-server protocol, which you generally don't need to worry about, but if you're running it on a Mac, it's kind of useful to know because of how Docker works. And the Docker binary lets you run things and build things and inspect things and get logs from things, all with the same binary. So Docker build-t, T is tag, Docker-presentation, and I say I want to build from my current directory. And this is what it looks like. And at every step along the way, you see a hash. The first one is A5EE blah, and the second one is 500D blah. Each of these is an image. The thing is, images are for sharing. You're not going to share every single intermediate build of that, or every intermediate image of that. But images are the granularity and means of distribution. So when I want to share something with somebody else, I do it with an image. And the verbs that Docker gives us to do this is pull and push, just like Git. So Docker pull says, I want to get an image from somewhere on the internet and bring it to my local machine. And Docker push says, I want to take an image that I've built on my local machine and send it to somewhere else on the internet. And that somewhere else is called a container registry. And there's lots of them. There's a default one that Docker, no coincidence, Docker runs, called, just if you go to hub.docker.com, it'll be there. I'm also C. Winters there. I don't have very much there, so it's not that great. But many others exist, and you can run your own. It's just using HTTP to do this stuff. So the thing is, that image that you build is everything you need to run your code. It is your code is in there, great. Your dependencies and their dependencies and their dependencies, and your runtime. So if you want to say that this should run with Ruby 2.2.3 or Python 2.7.12, that version of Python will be in that image, and all of the stuff that it needs to run. And some of that might be supporting libraries, like if you're talking to Postgres, there might be the libpq and all of the stuff around Postgres. It's all there. And it has a name. So if we go back, a version is a name of your code at a point in time. The thing that Docker gives it is it makes that name runnable by anybody. So if we pull, this is the image we use in our build process called Swagger CLI. Swagger is just a way to document APIs. And you can use JSON or YAML to do this. JSON is terrible for humans to write in, so that's why people pick YAML. And one thing that happens a lot is you have to validate it. There's requirements to different parts of documenting the API, and sometimes people fat finger things because we're humans. So as part of our build process, and we run unit tests, and we also check to make sure that it's a valid file. So we use a Docker image to do this. And there's one called NKT Pro, I think refers to a company, I'm not sure. But there is, if you go on hub.docker.com, you can find this image. And somebody has put the Swagger command line interface into a Docker image for us. So the first thing we do is pull it. And I issue a Docker pull, and this is what it looks like. This is actually the full output of that. And we see that it's bringing 1, 2, 3, 4 images down, and then bundling them all into one image, which has this hash associated with it. And then we run it. So say I have a Swagger YAML file in my current directory, and I want to run this Docker image. I'll give it this invocation, which I'll go through a little bit. And it just says Swagger YAML is valid. Awesome. And it also gives if it's not valid, it returns a non-zero exit code, so it plays well with all the other Unix utilities and things like continuous deployment pipelines. So if we look at that, if we break that down, The first thing is Docker run. So we're still using that same Docker binary, but instead of building something, or pulling something, or pushing something, I'm saying I want to run an image. So the next thing is we want to take our directory and make it available to the container. Here I'm just saying my current working directory, my present working directory, I'm going to mount in the container as app/app. There are ways to do this as read-only or things like that, but for our purposes, we don't care. And there's our name. We say we want to use this image name that we pulled down before. If you didn't pull it down before, Docker will go get it for you. And then the next thing is just the command we actually want to run with this, which is called validate, and then we give it a path to our Swagger file. And that's it. Which seems more complicated than running it just from the command line yourself. But these are things I do not have to care about anymore. I don't care what language this is written in. I don't care what libraries it uses. I don't know what version of Node it even requires. Does it work with the one I have locally? Do I have to install something else? Do I have to use NVM or RVM or any of those things? No, because it's all there. I don't need to create a virtual environment or a gem spec or any of these things that makes tools difficult to use. I can find out if I want, though. So it's an opaque box, right? So it's not a black box where I just get a tool and I have to use it and whatever they give me is what I'm stuck with. I can look at that. So the image is a result of Docker build, and build generally uses Docker files. And Docker files are just text. So this is a Docker file for this particular image. The first line says from mhart alpine node, which is Alpine is a distribution of Linux. This is a Linux-only thing, by the way. Again, you can find this out on the internet if you check it out. But, the second line says, I'm going to run npm and install the Swagger CLI, and then I'm just going to run Swagger. This is like just about the simplest Docker file you can possibly have. But you don't have to do this from scratch. Like somebody else has already done this for you. Somebody else has packaged up this utility with a particular version of Node, with a particular version of the code, and it all just works. So that first line is deceptive, right? Because it has a name in there. From is for sharing, right? It's like, oh, hug. From is hugs. And there's a name for us again. We have a name, this universal name that we can use to reference that thing from anywhere in the internet. And someone else has done this for us. Like someone else had an itch. They're like, I want to run Swagger CLI. And they bundled us up and made this available for reuse for other folks to use. And we can use it as is, or we can build on it if we want to. So the thing is, for all, not all, I can't say all because this isn't universally true, but for a large percentage of the tools that you probably use right now, somebody has probably already made an image for that. So if you use databases or apps, like entire apps, people have Dockerized so that you can run them locally without installing a whole bunch of stuff around it. And similarly, if you want to try out a new version of Node or Python or a compiler that might be in beta, there's probably a Docker image for that so you can test it out without having to install everything locally. So what does this all mean? So what this means, you have a way to share your code, plus its runtime, plus its dependencies, and enable running as is, or make it available for people to extend from any machine on the internet, which I think is pretty cool. You say, well, is it actually the same thing? Like, I run this image, am I gonna, I run this image, and Steve runs this image, and Joe runs this image. Are we all actually getting the same thing? Well, yes, but most things that you run need some sort of state around them, right? So the thing that still varies is your environment. And this is where Docker containers come in. So the image, a Docker image is a result of a build. A container is a running image. And so a lot of times the first thing that people ask is, can I run more than one container from the same image on my machine? And I would counter that. I would say, Docker container, if you think about it as a virtual machine, you get tripped up. Do not think of Docker containers or images as virtual machines, because they're not. Instead, think of it as a binary that you execute that has all the stuff around it that it needs to execute. So if you rephrase that question and you said, can I run more than one process from a binary? Can you run more than one Ruby program at the same time? Can you run more than one JDK? Of course you can. This is Unix. We have multiple processes. So a container is a running process. And if you just think, like if you do a Docker PS, which lists all the running container, if you just think of those as processes instead, the idea that they're virtual machines kind of goes out of your mind. And Docker makes this, once you start using it, makes this more known with signals. So if I send a kill to a Docker container, it respects all the normal Unix signals. So if I send a hup or a kill-9 or anything like that, it will send that to the process running in that container. And when you look at the standard error or the standard out for that container, it is from that process that's running in there. So but still the sticky point there is what does needs to run mean? So what do you typically need to run? You need some sort of environment to run in. So sometimes this is environment variables, sometimes it's other things. You need a network, because most things need to talk to other things. And storage, you need a place to put stuff, right? And so this is where 12-factor stuff comes in and helps you think about how to manage that in a more straightforward and useful way. So who knows what 12-factor apps are? Okay, cool. So this is not a quiz. Who's using 12-factor apps in production? Cool. It's good. So similar to Docker, 12-factor is a way of viewing the world. There's a, if you go to 12factor.net, you can read all of the 12 factors. And they have some additional information about each one of them. But it's not a recipe. They're not going to tell you exactly what to do. It's more of, if you follow these general steps, then your life will be much easier. And these are a few of them. The first, it's useful to know that these came out of the folks from Heroku. So these were kind of distilled from their experience of running Heroku and things that they learned along the way. And just like Carol said earlier, thank you for sharing. Because it's very nice to be able to not have to explain these things again and again. You say, go to 12factor.net and read that, because very smart people wrote it. And it is hard-won experience. Like every single one of those things you read, just imagine all of the errors underlying all of that stuff. It's very humbling. So the first one is, first in my list, I numbered them just so you have a reference, is run stateless processes, if you can. The second one, configure your application via the environment. Use stateful services over the network. These are all kind of abstract, and we'll go through them one by one. And log as a stream and not to files. So if you don't follow Andrew Clay Schaefer on Twitter, I recommend it, little idea. So this is, a lot of times when people talk about Docker, like the standard talk that I would be giving, would be to talk about all the awesome things you can do with continuous deployment and how Docker makes that easier, right? But actually, what he's saying is, that's a way to get people in the door, but then you hammer them with 12-factor stuff and get them to write applications kind of the right way, because it winds up being necessary to make all this stuff happen. So stateless. A lot of times we use files when we write applications without even thinking about it. So we have files we read from for a configuration, and then we have files we write to. Or we have things we write to in memory that we're not even thinking of state, right? So a lot of times we have files or sessions, right? We keep session state in memory. The problem is, now I can't run multiple processes, because I have to remember if Joe hit this particular instance of my up the first time, he's going to need to keep going to that because his state is stuck in memory. So instead of trying to figure out where that state is, you need to put it somewhere on the network so everybody can read it, which sounds complicated, but the world has evolved in the last 10 years to make that really easy. So if you're on Amazon, you can stick things in a file, but that's not as quick to access. Or if you're using almost anything, you can use some sort of cache. And Redis and Memcache are super, super easy to use and get started. So a lot of times if you look at people running Docker things, you see all these environment variables they're passing around. And it feels very Stone Age, right? Like, haven't we evolved beyond this? Like, why are we still using environment variables? Things are really easy. And you can still have dynamic configuration files, but you put the variances in the environment. So where does my database live? Where's my email server? What is the key and the password I need to contact that email server over an API? Where are my logs going? Where are my errors getting reported to? Like, all of these sorts of things vary depending on whether I'm running locally on a staging environment or a production environment. So I need to find all of those things, stick them in the environment. So the sticky sessions, so a lot of things, even Amazon still does this, it gives you the option of having sticky load balancers. So if someone goes to load balancer, through the load balancer, hits application A, the load balancer will try to make sure that that person always hits application A, but this is a crutch. And this is, so you can keep this stuff in memory, and you'll regret it, basically. This is a lesson of 12-factor stuff, is you can do other things, but you'll regret it once you start scaling up. So if you need multiple databases, for example, you just have multiple URLs that point to these things. And one of the side effects of configuring via the environment is changing that configuration is really easy. You don't need to go into a file in a running application. Typically, you'll just kill it and start it with a new configuration and be on your way. So like I mentioned before, with Docker, the standard out and standard error of a container will be whatever that process is that's running inside it. Docker, by default, will just throw these things in the stream of logging events. It'll throw them into a JSON file, which isn't awesome to use by itself. But you can also send that other places. There are log drivers that you can configure, and you can say, I want you to send this to a syslog, or I want you to send this to CloudWatch, or all these other things. You also don't have to rely on Docker for logging. There's a couple of options that we looked at when we started logging from Docker containers. So either every container sends its logs to an aggregator, and that aggregator presents a common view of the log for us, or every container logs to another one that aggregates. And I'll skip the hands. So this is the what we're doing right now. So every container sends to another container running on that same machine, that same kind of physical machine, because it's all virtual machines under the hood. I don't think there's any actual metal running anywhere. It's all just virtual machines. So the green is an rsyslog container, and it gets all of the log messages from the local containers and then forwards them on to a log aggregator, which for our case right now is Loggly. The other neat thing is, if we wanted to, now that that's in one place, this is kind of normal abstraction type stuff, right? It's in one place. If we wanted to try out a different logging service, we could have that rsyslog container send it to Loggly and to somebody else, and we could see what they're like literally side by side, because they're getting the same messages. So there's other neat things, but I'm nearing the end of my time. Okay, this feels like operational stuff, and operational stuff is boring, right? I mean, honestly, who likes running things? That's somebody else's job. This is from one of the best movies ever, by the way, War Games. I don't know if anybody. But the thing is, operational stuff, like Matt was talking earlier, it's kind of like unit tests are quality stuff. Like, who cares about quality? Well, everybody cares about quality, and it winds up changing the way you think about things, right? I bet if you write tests more frequently, like Matt was talking about, that you're going to change the way that you write your code as a result. And hopefully change the way you approach problems. And that's a powerful thing indeed. That's it.